In today's lesson, we are going to be looking at the sine law again. However, we're going to be looking at how to solve or how to find missing angles using the sine law instead of looking for how to find missing sides. Now, it's going to be very similar to our last lesson because it is the exact same formula and it's almost the exact same process, just with one extra step. So again, with a reminder, when we're dealing with acute triangles or triangles that do not have or the triangles that basically do not have a right angle and have all angles under 90 degrees, we can actually use what's called the sine law to find missing sides and angles. So again, we look same formula as before, and it's all basically ratios between the sine of an angle and its corresponding side. So we have all of these pairs of sides and angles. So there's a pair here with this angle and the side A. There's a pair here with B and side B. And then there's a pair here with C and side C. So there's three pairs, three ratios, right? We're not using all three at once when we solve these problems, but we are dealing, it's just basically showing that it's all equal. So it doesn't really matter what ratio I use or what pair of sides I use, they are all equal to each other. However, when we do solve these problems, we are looking for that full pair and that half pair like we mentioned in the last one, or in the last lesson, and we will only be using two pairs at a time. So even though that all three are equal to each other, we're only going to be using two. So let's go through an example about how to use the sine law to solve for a missing angle. Well, in this case here, we're going to solve for angle Q. So I'm going to look for this angle here. It is angle Q. Put a question mark just so we know that that's the angle we're looking for. So I need to have a full pair and a half pair. In this case, we can see that we have a full pair here with R, and we have a half pair here with our side and our angle. So we have enough information to go through and use our sine law. So we're going to set up a ratio between the R pair and the Q pair. So sine of R over little r is going to equal sine of Q over little q. I'm going to fill in my information. So sine of R, which is angle 58, over the side length of 30, is equal to sine of Q, which we don't know, divided by side Q, which is 23. Again, we have fractions here, so we want to get rid of them. We're going to cross multiply. So I get 23 times sine 58, which is equal to 30 times sine Q. I want to get Q by itself. So before I get rid of the sine, I'm going to get rid of the 30 by moving it over to the other side. Very similar to our last lesson where we got rid of a value to isolate for our variable. So we get 23 sine 58 divided by 30 equals sine Q. Now this is very similar to our last lesson, and we would basically be left with a variable on one side and we calculate the other side to get our answer. However, if I go through and calculate the one side, 23 times sine 58 divided by 30, we get 0.6502 equals sine Q. That doesn't quite make sense for an angle. There is one last step, and we might already know or kind of guess what we have to do, but this looks very similar to when we were solving for our sine ratio and we needed to solve for an angle. Right? So I need to move the sine to the other side or cancel out the sine on the one side. So what is the opposite of sine? Well, it's the inverse, sine -1. So similar to our sine ratios or our right angle trig ratios, when we had to solve for an angle, we had to use the inverse. The same thing is true with our sine law. We still have to use the inverse for that very last step. So the inverse of sine of our value that we got gives us an angle of 40.55. We'll say 40.6 degrees equals Q. So it's very similar to our previous lesson where we had to solve for a missing side. We're cross multiplying, we're bringing something over to the other side and dividing. The only difference here is this inverse. So different from last lesson. So this whole kind of step here is different from the last lesson. And that's the difference between finding a side length and finding an angle using the sine law. Let's go through one more example just to make sure we're kind of comfortable with these steps. Like I said before, again, most of these steps are similar to the previous lesson. So as long as you practice that, you should have at least a good grasp on the beginning portion of solving for an angle. I want to find my full pair and half pair. So here I do see a half pair and I see a full pair. So I have enough information. So sine of angle C over little c equals sine of angle B over little b. Again, the order doesn't matter. I could put B first and C second. It doesn't really matter. We just want to make sure we're consistent. So if I have angle C or sine of angle C on top, little c should be on the bottom, right? And I could flip it as well, have the reciprocal. I could have the side on top and sine of the angle on the bottom. Again, it's the same kind of idea. I'm going to fill in my information. So sine of angle C, so 79 divided by 32 is equal to sine B, or we'll call it X now, divided by 27. Cross multiply. We get sine 79, or sorry, 27 times sine 79 divided by, or not divided by yet, equals 32 times sine x. I want to get sine x by itself, so I'm going to move the 32 over. I get 27 times sine 79 divided by 32 equals sine x. The very last step, to get x by itself, we need to do the inverse. So sine -1 of 27 sine 79 divided by 32. And if you're comfortable with your calculator, you can do all of this in one step. Depending on your calculator and depending on how comfortable you are, you may have to take it step by step. Multiply the top first, then divide by the bottom, and then put it in to your inverse. But we should get 55.9, or this one we can probably better off to round to 56 degrees for x. So I'm going to double check because I tried to do that all at once, so I just want to make sure that I don't have the wrong value. I was able to enter it correctly. Our answer should be 56. One last question. So Mr. Liu is helping his cat hunt for birds. They have spotted a robin up in a tree. The distance from Mr. Liu to the bird is 7.8 meters, and the distance from the cat to the bird is 5.9. What is the angle of elevation, if the angle of elevation between myself and the bird is 36 degrees, what is the distance between myself and my cat? So we have our diagram here, kind of a rough triangle. We have our angle of elevation entered. We're seeing that the distance from myself to the bird is 7.8. From the cat to the bird is 5.9. And we're trying to find how far apart we are. Looking at this though, I don't have enough information to help me find how far apart we are. That's this pair right here. But there's no information in any spot. I don't have the angle and I don't have the side length. If I did have the side length, that'd be great. I'd be done. I wouldn't have to answer anything. What I do have though, is I have a full pair here and oh, I removed it. and a half pair here. So I can use my sine law to find this missing angle here, which I can then use in conjunction with the other angle to find my missing angle at the top, and then I can use my sine law to find that last missing side. So I'm going to find this missing angle first. We'll just say sine C just because that's where the cat is or where Chester is. So sine C divided by little c equals sine, so we'll call this C. Let's just keep it consistent. We'll call this A, and the bird will be B. So sine A over little a. Sine C we don't know, but divided by side C, which would be 7.8, equals sine of 36 divided by 5.9. We want to cross multiply. So we get 5.9 sine C equals 7.8 sine 36. I want to get sine C by itself, so I'm going to move the 5.9 over. We get sine C equals 7.8 times sine 36 divided by 5.9. Now we're not quite there yet. We need to still get our angle. So to get our angle, I have to move the sine over or do the inverse. So the inverse of sine, or sine -1 of 7.8 sine 36 divided by 5.9. And we get an angle of 1 second. Going through and calculating, we get an angle of 51 degrees. So we have 51 degrees now down here. I can figure out this missing angle at the top because I can do 180 minus 36 minus 51. And I'm left with 93 degrees. So I have 93 degrees at the top. I now have enough information to go through and find my missing side length along the bottom. So I'm going to use a second sine law formula. We're going to do the sine law again. Just take this, just shrink it a little bit. I'm going to do sine law again. I have sine of, we'll do A because we were given all that information, so I know A is good. So sine A over little a equals sine B over little b. Sine of angle A, so sine of 36 divided by 5.9 is equal to sine of 93 divided by x. So this part goes back to what we looked at previously in our previous lesson, solving for a side length. We're going to cross multiply. X times sine 36 is equal to 5.9 times sine 93. I want to get x by itself, so I'm bringing the sine 36 over. Let's move this just kind of up. So we have then x is equal to 5.9 times sine 93 divided by sine 36. This just becomes a calculation. And we get a value of 10.02. So that is how far apart myself and Chester, or my cat, are. We are 10.02 meters apart, or across from each other. So that's how we can use sine law to find a missing angle, which we can then use with sine law again to help us find a missing side. So again, very similar steps to in comparison to the last lesson. That is the nice thing about sine law. There's not too many, or the process is fairly similar. There is that last added step of having to use the inverse of our sine ratio to get our value or to get our missing angle. But other than that, the rest is the same. We're still cross multiplying, we're moving something over and dividing, and then we're calculating at the end, but then we have to do the inverse. So again, make sure you are comfortable finding an angle or a side length using the sine law.